Now, let's do one more example, guys. Can you guys tell me, since we figured out that H2O was, I already told you H2O is polar, can we prove that H2O is polar? So guys, first you have to draw the Lewis structure. Then you will be telling me the molecular geometry, and then the molecular polarity. The first thing is Lewis structure. Then next is molecular geometry. And then the last is the polarity. So guys, do the steps for drawing the Lewis structure for H2O.
Total valence electrons.
Yep, so the first step is your total valence electrons. So hydrogen, how many guys?
1.
So 1 times 2 equal 2 electrons. And then oxygen is
6.
the total is
6.
8.
Total is 8, right?
8.
6 from oxygen, 2 from hydrogen, total 8 electrons. Who should go in the center, guys? Hydrogen or oxygen?
Oxygen.
Hydrogen never goes in the
This is
center.
lesser number since you have 2 hydrogens and 1 oxygen. Oxygen will go in the center. Okay. Right. Then you have 2 hydrogens sitting like this. Now, what do you do next?
At the bonds.
You make the bond. So you make the bond like this. That used how many electrons?
4.
So out of 8, we have used 4 electrons in bonds, and then we're left with 4 electrons. So now what do you do with these 4 electrons? Do they go to hydrogen, guys? Because you have to give them to the outer atoms first. So can we give them to hydrogen?
No.
Yeah.
No.
No, you
Remember, hydrogen does
give it
not
to
take,
hydrogen.
right?
Oh.
So even though it's sitting at the outer, but hydrogen never takes extra electrons. So you have 4 electrons. So what do you do here?
Use give them to oxygen.
The oxygen.
To oxygen.
2 on the top and 2 on the bottom.
Right. So you're going to show as lone pairs. So you can show that there are 2 lone pairs like that, right? Okay. Now, what's our next step?
Molecular geometry.
Symmetry.
You guys are running way far ahead.
Octet.
Octet rule.
Yes. First finish the Lewis structure. Yes. So for Lewis structure, yes, the last step is the octet. Hydrogen does not care about octet. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is good. So yes, this is our final structure for water. Okay. Now, how do you decide the molecular geometry, guys? For that, what do we need?
Count the number of neighbors.
We need, remember, we need this chart for molecular geometry. So for molecular geometry, guys, for H2O, what do you think? What should you do first? What do you find first?
Electronegativity.
No. See, again, I'm talking about molecular geometry. I'm not talking about polar, non-polar, guys.
Oh,
With the shape.
Neighbors. The number of neighbors.
Neighbors. So how many neighbors total?
4.
2.
2.
4.
Two
Oh,
neighbors.
4.
So guys,
Yep.
by neighbor, oxygen is 2 hydrogen neighbors. And remember, lone pairs count as a neighbor, right?
Yes.
So when
Yes.
you say total, we are adding all of them. So total 4 neighbors, out of which how many are bonded neighbors?
2.
2 are bonded, and how many are lone pairs?
2.
2 lone pairs. So it's 4, 2, 2, right? So if it's 4, 2, 2, and I go back to the table here, 4, 2, 2 is suggesting what shape?
Bent.
It's suggesting bent shape. Okay. So I go here, and then I say that the shape, the molecular geometry is bent. This is my second response. The first response was the Lewis structure that he figured out. Molecular geometry is bent. Okay, so this is your molecular geometry. This was the Lewis structure. What's the third thing, guys? Polarity? So guys, tell me for polarity, what do you need to look at? For polarity, when we say polarity, guys, we're talking about the molecule's polarity, okay? Molecular polarity. So for this, guys, what do you do?
Electronegativity.
So for this, first of all, remember we need 2 things to look at. What are those 2 things called?
Bond polarity and symmetry.
You look at the bond polarity and
Symmetry.
the symmetry. All right. So guys, here you got to tell me, what do you think about the bond polarity? So when I'm looking at bond polarity, which two atoms am I looking at? Which bond am I looking at?
Oxygen.
The OH.
You're looking at OH. You're looking at the OH bond. So do not think of multiplying with 2 or dividing by 2. You just look at the OH bond. Either look at the right-hand side OH bond or look at the left-hand side OH bond. It's the same thing. So oxygen is how much, guys, in that table?
3.5.
3.5. And hydrogen is how much in that table?
2.1.
2.1. So what is the difference?
1.4.
1.4. Where does 1.4 fall? Into polar or non-polar category?
Polar.
Polar. So guys, for bond polarity, what is my answer? It is polar. Is this my final answer, guys?
No.
No.
We still need to look at the symmetry, right? And guys, tell me, symmetry goes with polarity or does it go against polarity?
Against it.
Goes against, okay? So now we have to look at the symmetry. Does this molecule look symmetrical to you, this water?
Yes.
No.
This symmetrical?
No.
What was the condition for symmetry, guys? Remember the two conditions I wrote earlier for symmetry?
Lone pair in the central atom.
Yeah, remember this one? That all the atoms must be same and there should be no lone pair.
Mm.
So do we not have a lone pair here?
The other pair.
We do have a lone pair, guys.
Yeah.
When if you're yes, because if you're thinking, look here, guys, on the screen. If you're thinking that this lone pair is going this way and this lone pair is going this way, then no, we do not have the complete picture. Okay, that is actually not what happens. Let me show you. You're not responsible for that, but you should understand this part. That remember we said it's a bent shape. This is what it actually means by bent shape. And you see where its lone pairs are actually sitting? Its lone pairs are actually sitting like this. This is how water lone pairs are actually sitting. If you draw the other way on the Lewis structure, I'm totally fine with that. That doesn't matter. But when we talk about the shape, the actual shape of water is this and not that shape on the top. Okay, so now, does this thing look symmetrical to you?
No.
For
No.
you, the one thing to remember, guys, is if you have a lone pair means no symmetry. If you guys remember that, you'll be all good. You don't have to think about any of these shapes.
And you mean on the central atom, right?
Yes, lone pair on
Thank you.
central atom. Yes.
Okay.
Okay. So now
So if the outside had lone pairs,
that we don't care about that.
okay.
We just care about the central atom. Okay. The central atom has lone pair or not. That's what decides everything.
Got it.
Okay. So for molecular geometry and for the polarity, our focus is only and only the central atom.
Okay.
So guys, what do you say? Yeah.
If lone pair means no symmetry, does that instantly make it polar?
Yes. So for symmetry, guys, what should I say here? Yes or no? Is this thing symmetrical?
No.
No. So if the bond is polar and there is no symmetry, what do you think the molecule is?
Polar.
Polar. Okay. So that's how you figure out if the molecule is polar or not.
A question.
Yes.
For the rule that you gave that all atoms must be the same,
Uh-huh.
what do you mean by that?
So this is what I mean by that. So if I give you this example here, C, Cl, 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 and Cl. You see how to the central atom, all the neighbors are same?
Yeah.
When they all are same, that is symmetrical. That's what it means.
So you do like the first step, and then if it's all symmetrical, you technically don't need to do the second step?
So let me ask you this. Does this look symmetrical?
No.
No. So no symmetry. And yes, symmetry here. So that's where I was saying that you want to make sure that all the atoms are the same.
Okay.
What were you asking again? Can you repeat your question?
That was my question.
Okay. So out of these two molecules, once you have these molecules, tell me, guys, Tell me your answer. Out of these two, which one do you think is polar and which one is nonpolar? Both could be polar, both could be nonpolar. What do you guys think?
First
the
is
ones-
polar and the second.
Okay, for molecules polarity, we're not
No
going to jump to
symmetry.
the answer, okay? We're not going to jump to the answer. For molecular polarity, what are the things that we look at?
Sen-
Bond polarity and
Yeah, so
symmetry.
the first thing is always bond polarity, okay? So never miss that part. We have to make sure that our bonds are polar, unless symmetry is not going to do anything otherwise. So first is bond polarity. What do you guys think? Are our bonds polar here? So by that I mean you look at the CCl bond or look at the CF bond. You need at least one polar bond in the molecule.
Yes.
So you have CCl. Carbon is how much, guys?
2.5.
2.5. And chlorine is
3.0.
the difference is how much?
0.5.
0.5. Does 0.5 qualify as polar?
Yes.
Yes. I can say that the bond is polar.
Mm-hmm.
Minimum, we need one polar bond. Okay. So the bond is polar. If the bond is polar, what is the second thing you look at?
Symmetry.
You look at symmetry. So for symmetry, does this molecule look symmetrical to you? Yes or no?
No.
No. So what is your final answer going to be? The bond is polar and symmetry does not exist to cancel it. So molecule is what?
It's polar.
Polar. So guys, in order to understand this, and you're going to see a couple of questions of this on your exam. And if you see 2 questions, that's against. So just to tell you guys, this chapter is 50% of your next exam, chapter 4, which is basically today's lecture and the previous lecture. The Lewis structure, molecular geometry, polarity. These 3 topics are giving you 50 points on your exam. Okay, so you need to understand when you're doing this kind of problem for molecule polarity, you must say this in a sentence. If you're going to say this in a sentence, this will make much more sense. So try to say it with me in your head. The bond polarity is yes. So there is a bond polarity. Yes, there is a bond polarity. And there's no symmetry to cancel it. That's how you should frame your sentence. Okay? There is polarity and no symmetry to cancel it. Then the molecule is polar.
Will it ever be where the bond is not polar and there is no symmetry?
Yes, that is possible. When the bond is, so whenever, see, this is possible when the bond is non-polar, but there's a lone pair.
Right. And that would make the whole molecule polar.
That will make the whole molecule polar. Lone pair has the capacity to make the molecule polar, even if the bond is non-polar.
Okay.
Okay?
Can we do one of those problems?
I'll see if I remember any of that example. Okay? Okay, but for right now, for the second part, for the second question that I showed you, CCl4, tell me guys, molecule polarity, bond polarity, what are you going to say? Is this polar or non-polar?
Yes, it is polar.
Because carbon was 2.5, chlorine is 3. So guys, first of all, you got to remember that when it's bond polarity, what do you look for? So you look for the difference. And yes, it is a polar bond. Yes, polar. Right?
Mm-hmm.
And the second thing, of course, you look at is symmetry. What is your comment, guys, on symmetry? Does this molecule look symmetrical to you, CCl4?
Yes, it does.
Yes.
Yes, it does. So guys, can you frame the sentence? So the molecule, so the bond is polar and there is symmetry to cancel it.
Mm-hmm.
Okay, so what do you think the molecule is?
Non-polar.
Non-polar.
You go potty in the toilet.
Does that make sense, guys?
Yeah.
Okay. So guys, if you have any questions, please don't hesitate asking me. I know this is maybe sometimes this is too much because that's too much of information for solving one problem.
Okay.
You guys don't hesitate asking me a question here.
Go ahead.
The first, the one that says carbon, then chloride and fluorine.
Mm-hmm.
So you only need to calculate the polarity of carbon and chloride.
Yeah. So you could have checked both because actually CF is actually better. You see, C is 2.5 and F is 4. So difference is 1.5. So you see that is also polar, and this 0.5 is also polar because the range is 0.5 to 1.8. Right.
Mm-hmm.
So the minimum requirement is one polar bond in a molecule. And you can say yes for the bond polarity.
But should you check all of the bonds just in case one is?
Yes, yes, you should. If you have multiple type of atoms, then you must. So let me give you an example for that, okay? So guys, let's do one example, and then you guys tell me the answer for this. So our next example is CH3Cl. So now guys, I'm not going to waste time here in making the Lewis structure. I'm already going to give you the Lewis structure. Okay, everyone see that this should be the Lewis structure for CH3Cl? Carbon in the center, 3 hydrogen and 1 chlorine, and chlorine has a lone pairs. Okay, now answer the remaining part, what we learned today, the molecular geometry part and molecule polarity part. For geometry, what do you look at, guys? You need that table, right? So for that table, what do you look at?
Electron groups.
So you look at the electron groups. So carbon has how many electron groups?
3. I mean
Yeah.
4.
It has 4 groups. So the formula is 4 total neighbors, out of which how many are bonded?
4.
4, and how many lone pairs?
4.
So 440 puts CH3Cl into which shape? 440. And 440 is tetrahedral, okay? So this molecule here, your answer is that this guy is tetrahedral. And remind me, guys, right after this, after we're done with this problem, I have to show you what tetrahedral actually looks like, okay? So we got the tetrahedral shape. Now, if I ask you for molecule polarity, what are the things that you look at?
Polarity. It's the bond polarity.
You look at the bond polarity,
And
you also look at the symmetry.
Symmetry.
Okay. So what's your answer for bond polarity? What do you guys think?
So it's going to be C is 2.5 minus.
C is 2.5.
Minus 2.1.
And H is 2.1. That gives you polar or non-polar bond, guys?
0.4 is polar.
Is it polar? Look at the table again.
Non-polar.
0.4 is non-polar, guys. Remember 0 to 0.4 is non-polar? So 0.5 to 1.8 was polar.
Wait, yeah.
Remember that?
Sorry, yeah.
2.5 minus 2.1 is 0.4, and 0.4 is non-polar.
Non-polar.
Okay. Now, so should I say for bond polarity that my answer is no?
To check the other bond.
You have to check the other bonds too. Yeah, this is CH, CH, and CH, so we don't have to worry about those. But you do need to worry about the CCl. Carbon is 2.5 and chlorine is how much?
3.0.
3.0, and that gives you a difference of
0.5.
0.5, which makes it what? Polar or non-polar?
Polar.
Polar. So you see we have a minimum 1 polar bond. So I can say yes for a polar bond. That's the minimum requirement, 1 polar bond at least. All of them can be polar, and that's fine too. Okay. Now for symmetry, what are you going to say? Does this thing look symmetrical to you?
No.
No. So guys, even if you have no idea about anything we learned today, you should be able to look at this and tell me that this thing is not symmetrical because it has 3 hydrogens and then 1 chlorine on the other side. So that does not look symmetrical, so no. So guys, how should I frame this sentence? There is a polar bond,
but there is no symmetry.
There's no symmetry to cancel the polarity, right? So that makes the molecule what? Polar or non-polar?
Polar.
Polar.
Okay. So I'm going to say this again, guys. Since the bond is polar and there's no symmetry to cancel that polarity, the bond molecule stays polar.